The first indication something was wrong came as a gentle vibration through the deck plating. Thok felt it through his primary manipulators. The subtle tremor carried a frequency that shouldn't exist aboard the research vessel Harmony's Edge. His species had evolved to detect such anomalies. On Senna Prime, unexpected vibrations usually meant the ground was about to open and swallow you whole. Environmental systems showing cascade failure across primary life support, announced Senna from the main console. Her voice carried the measured calm of someone reporting routine data. Her people didn't panic. They simply calculated odds and prepared for outcomes. Thok's throat sacs inflated slightly. Not panic, just increased oxygen intake for enhanced cognitive function. Time to critical failure, 5 hours, 43 minutes, plus or minus 12 minutes depending on current atmospheric recycling efficiency. The human maintenance specialist looked up from her meal tray. Me had been eating something that smelled like burnt vegetation. Thok never understood how humans consumed plants that had clearly been damaged by fire. "What kind of failure are we talking about?" Me asked. She took another bite of her burnt plant matter. Senna's crest feathers displayed information in rapid color patterns. Primary atmospheric processors offline. Backup systems compromised. Secondary recycling units showing critical stress fractures in the filtration matrices. Me stood and stretched. Her joints made small popping sounds that always made Thok's skin crawl. Sounds like Tuesday. Thok exchanged a glance with Senna. Neither of them understood the human reference to planetary rotation cycles. "Me," Senna said carefully, "we have less than 6 hours of breathable atmosphere remaining." "Yeah, I heard you." Me walked over to the food preparation unit and started examining its exterior panels. "Anyone mind if I take this apart?" "Take apart the food processor." Thok's throat sacs deflated in confusion. "Why would you want to?" "Me, we need to focus on life support repairs." "I am focusing on life support repairs." Me had already removed 4 access panels. Her hands moved with practiced efficiency. "Hey, Senna, what's the power draw on this thing?" "Approximately 1,400 standard units per hour during active operation." "Perfect." Me started disconnecting power couplings. "And the atmospheric composition we need to maintain." Senna's feathers rippled with bewilderment. "Standard Class 12 breathable mixture. Oxygen at 21%, nitrogen at 78%, trace gases at appropriate levels." "Right. Same as home." Me had moved to the exercise equipment. She was taking apart the atmospheric regulation unit on the treadmill. "Thok, you mind grabbing me that toolkit from the maintenance locker?" Thok retrieved the tools, though he felt like he was contributing to some form of madness. "Me, I don't understand what you're trying to accomplish." "Making air." She had opened the waste recycling unit and was examining its internal pumps. "This is actually going to be easier than I thought." "Making air from exercise equipment." Senna's crest feathers had shifted to colors Thok had never seen before. "Making air from parts that move air." Me pulled a circulation fan from the recycling unit. "See, you guys are thinking about designated purposes. This is a food processor, so it processes food. This is exercise equipment, so people exercise on it. This is waste recycling, so it handles waste." She held up the fan. "But I just see a device that moves air at a controlled rate with adjustable flow patterns." Thok watched as Me began connecting the fan to power couplings from the food processor. "That's not how engineering works." "Really?" Me grinned. "Watch this." For the next hour, Thok and Senna observed what could only be described as organized chaos. Me dismantled 17 different systems throughout the ship. She took apart everything from the drink dispensers to the holographic entertainment unit. Each component ended up in a growing pile near the main environmental systems panel. Me worked with casual efficiency. She hummed something that Thok's translator couldn't identify. Human music apparently didn't follow universal patterns. The molecular bonds in those components aren't designed for atmospheric processing, Senna said as they reached the 4-hour mark. The stress tolerances alone should cause immediate failure. Why? Me was connecting fluid pumps from the hygiene systems to air circulation units from the food storage area. Metal is metal. Plastic is plastic. What matters is what shape they're in and how fast they move stuff around. Thok species had developed engineering over 12,000 years of careful advancement. Every component had been tested, refined, and certified for specific applications. There are safety protocols, compatibility standards, efficiency ratings. Sure, Me held up a modified air filter. This filter was rated for processing liquid waste. Now it's processing gaseous waste. Same job, different medium. She had somehow integrated the filter with pumps, fans, power regulators, and what appeared to be the heating element from the beverage dispenser. The entire assembly looked like something a child might build from random parts. "This cannot possibly work," Senna said. Her feathers were now cycling through colors that indicated complete cognitive overload. "Sure it can." Me activated the device. It made a gentle humming sound. The air circulation indicators on Senna's console immediately began showing improved readings. How? Thok stared at the improvised life support system. How is that working? Physics. Me started connecting additional components. Air needs to move, filters need to clean it, pumps need to circulate it, heaters need to regulate temperature. All these machines were already doing those jobs for their specific purposes. She gestured at the food processor components. This thing was already moving air to keep food fresh. I just redirected it to move breathable air instead. The atmospheric readings continued to improve. Thok's throat sacs relaxed as the air quality stabilized. The exercise equipment was already regulating humidity and temperature for user comfort, Me continued. Same principles work for general life support. Senna's feathers had settled into a single color that Thok recognized as deep confusion. But the molecular filtration requirements are handled by the waste recycling filters. Me pointed to another component. They were already set up to process atmospheric contaminants. I just scaled up the intake flow. The life support readings were now better than they had been before the original system failed. "This is impossible," Thok said. Me was making final adjustments to her improvised system. "This is just Tuesday." She reached into her toolkit and pulled out a small device. She connected it to the air circulation system. Suddenly, the air began to carry a sweet, pleasant scent. "What is that smell?" Senna asked. "Vanilla." Me packed up her tools. Figured as long as we're breathing recycled air, it might as well smell nice. Thok sat down heavily. His legs felt unsteady. "You built a complete life support system from kitchen appliances and gym equipment. And waste management systems. Don't forget the waste management systems." Me headed toward the door. "Those pumps were the key to the whole thing." "But how did you know it would work?" Me paused in the doorway. "Same way I know anything works. I understand what the parts do, not what they're supposed to do." She left Thok and Senna alone with their improvised life support system. 20 minutes later, Thok's personal communicator chimed with an emergency signal. "Now what?" he muttered. The message was from Engineering Deck C, critical failure in the main power coupling system. The backup generators were offline. They had maybe 2 hours of stored power remaining. Thok found me in the ship's small workshop area. She was humming and examining what appeared to be the components of their communications array. "Me, we have another problem." "I know." She held up a power coupling that looked like it had been rebuilt from scratch, already on it. "You know about the power system failure. Felt it in the deck vibration about 10 minutes ago." Me was connecting the modified coupling to what looked like parts from the waste heat recovery system. Different frequency than the life support problem. Senna arrived, her feathers displaying rapid patterns of distress. The main power grid is completely offline. Emergency power won't last more than 90 minutes. Yep, me had started disassembling the ship's internal lighting system. Good thing we don't need 90 minutes. Thok watched as she began connecting light fixtures to power couplings to heat recovery units, and heat recovery units to what appeared to be the motor from the automatic door systems. What are you building now? Distributed power grid. Me removed another light fixture from the ceiling. The main system failed because it was trying to push too much power through centralized pathways. She gestured at her growing collection of components. So instead of one big power system, we build lots of little power systems. That's not how power distribution works, Senna said. Her feathers were stuck on a single color that Thok had learned meant complete intellectual surrender. Sure it is. Me activated her first improvised power cell. The lights in the workshop immediately brightened. Every device that uses power can also make power if you run it backwards. She pointed to a light fixture she had modified. This was converting electrical energy to light energy. Now, it's converting thermal energy from the waste heat system into electrical energy. Thok felt his throat sacs deflate completely. You turned lights into power generators. Some of them. Others are still lights. Depends on what we need where. Me moved to the next section of corridor. The door motors work great as rotational power converters. The air circulation fans can generate power when they're not actively moving air. Over the next hour, me installed 17 improvised power generation systems throughout the ship. Each one was built from completely unrelated components. Each one somehow worked perfectly. The main power grid readings showed stable power distribution across all ship systems. I need to update my engineering databases, Senna said quietly. Update them with what? Thok asked. I have no idea. They found me in the ship's small recreational area. She was drinking something from a container that steamed slightly. What's that? Thok asked. Coffee. Me took a sip, made it with the new power system. Figured I should test it with something important. Coffee is important. Coffee is how humans make sure their brains work properly. Me gestured at her improvised power grid. Can't do good engineering without proper brain function. Senna's feathers had started cycling through colors again. How is your coffee maker getting power? Same way everything else is getting power, from whatever's convenient. Me pointed to a series of connections that seemed to involve the wall-mounted emergency medical scanner, 3 light fixtures, and what might have been part of the food storage temperature control system. That can't be safe, Thok said. Why not? Me finished her coffee. Everything's working at design tolerances, just not designed purposes. She stood and stretched. Her joints made their usual popping sounds. Speaking of which, I should probably check on the navigation system. What's wrong with the navigation system? Senna asked with the tone of someone who was afraid to learn the answer. Nothing yet, but I felt another vibration change about 20 minutes ago. Different frequency signature. Me headed toward the bridge, probably just a routine calibration drift. Thok and Senna followed her. On the bridge, the navigation console was displaying error messages in 3 different languages, none of which Thok recognized. Routine calibration drift. Senna's feathers were now displaying colors that didn't exist in her species' normal emotional spectrum. Yeah, me was already removing access panels from the navigation computer. The quantum positioning sensors got confused by all the power fluctuations. They're trying to figure out where we are in relation to where they think we should be. And that's routine. For humans, yeah. Me pulled out what appeared to be the entire central processing unit of the navigation system. We get lost all the time. That's why we're good at finding our way back. She began connecting the navigation processor to components that definitely hadn't come from navigation systems. Thok recognized parts of the entertainment system, the personal hygiene facilities, and something that might have been from the emergency beacon array. "What exactly are you doing?" he asked, teaching the navigation system to think like a human. Me made a final connection. "Instead of trying to calculate exactly where we are, I'm having it figure out approximately where we are and then correct from there." The navigation console immediately stopped displaying error messages. Instead, it began showing their current position with what appeared to be perfect accuracy. "How does approximate navigation give exact results?" Senna asked. "Because exact calculations require exact information. If your information is wrong, your calculations are wrong." Me pointed to the display. "Approximate calculations work with approximate information, much more flexible, but less accurate. Actually, more accurate. See, if you try to be exactly right and you're wrong, you're completely wrong. If you try to be approximately right and you're wrong, you're still approximately right." Thok stared at the navigation display. "That doesn't make sense." "Makes perfect sense. Humans navigate by landmarks, not by mathematical calculations. So I taught the navigation system to look for landmarks. In space, sure. Stars, gravitational fields, radiation signatures, subspace distortions. Plenty of landmarks if you know how to look for them." The navigation system was now providing course corrections with better precision than Thok had ever seen from standard navigation equipment. His personal communicator chimed again. This time, the emergency was in the ship's main cargo bay. Environmental containment, failure in the specimen storage area. 3 different research samples were now loose in the ship's atmosphere. "Samples?" Me asked as they hurried toward the cargo bay. "Atmospheric microorganisms from 3 different worlds," Senna explained. "They're not supposed to interact with each other, or with us, or with ship systems. What happens if they do interact? Unknown, potentially catastrophic biological contamination." They reached the cargo bay to find atmosphere readings that looked like a chemistry experiment gone wrong. The air was filled with what appeared to be 3 different colored mists. "Biological hazard protocols require immediate evacuation and containment," Senna announced. "Or we could just fix it." Me was already examining the failed containment units. What do these microorganisms actually do? They process atmospheric gases according to their planetary evolutionary parameters. So they eat air and make different air. That's technically accurate. Great. Me was removing components from the failed containment system. Then we just give them the right kind of air to eat and the right place to make new air. She began connecting the containment units to what appeared to be parts of the air circulation system, the waste processing system, and something that might have been from the artificial gravity generators. "You're going to contain biological hazards with life support equipment. I'm going to give biological hazards jobs." Me activated her improvised containment system. "This microorganism likes to eat carbon dioxide and make oxygen. Perfect. It can help with atmospheric processing." The red mist in the air began to dissipate. "This one likes to eat organic waste products and make inert compounds. Great. It can work with waste management." The blue mist started concentrating around the waste processing connections. "And this one likes to eat electromagnetic radiation and make, well, I'm not sure what it makes, but it's not toxic to carbon-based life forms." The green mist began collecting around the artificial gravity components. Within 30 minutes, the cargo bay atmosphere was cleaner than it had been before the containment failure. "You turned a biological contamination crisis into an efficiency upgrade," Thok said. "I gave 3 lonely microorganisms friends to work with." Me checked the atmospheric readings one more time. "They're much happier now." "How do you know they're happier?" "Look at the readings. They're working at optimal efficiency levels." In the wild, microorganisms only work that well when they're in balanced ecological relationships. Senna's feathers were now displaying colors that Thok was pretty sure weren't physically possible for her species. You created an artificial ecosystem in our cargo bay. I created a working relationship between compatible biological systems. Me headed back toward the main corridor. Same thing, different perspective. By the time they reached the ship's common area, Thok had lost count of the number of impossible things Me had accomplished in the past 6 hours. The Harmony's Edge was now running on improvised life support, jury-rigged power systems, cobbled-together navigation, and what was apparently a cargo bay ecosystem. Everything worked better than it had when they started. Thok said carefully, do all humans approach problems this way? What way? By ignoring everything we know about how things are supposed to work. Me considered this. We don't ignore what you know. We just don't let what you know limit what we try. But there are rules, protocols, safety standards. Sure, rules are useful for normal situations. Me gestured around the ship. This wasn't a normal situation. What was it then? Tuesday. 3 hours later, when the rescue ship arrived, they found the Harmony's Edge running at better than optimal efficiency across all systems. The rescue captain, a veteran of 40 years in deep space operations, spent an hour examining Me's various modifications. I've never seen anything like this, he told Thok. The design principles don't match any known engineering framework. It's human engineering, Thok explained. Human engineering doesn't follow frameworks, Senna added. It follows physics, I think she said. The rescue captain made extensive notes on his official report. And all of this works. Better than the original systems, Thok confirmed. What did she call this approach? Thok and Senna looked at each other. Tuesday, they said in unison. The rescue captain's expression suggested he was beginning to understand why human engineers were both highly sought after and carefully monitored throughout the galaxy. In the maintenance bay, Me was teaching 2 junior crew members from the rescue ship how to modify atmospheric scrubbers using parts from the ship's laundry systems. The key is not to think about what something is supposed to do, she was saying. Think about what it actually does. One of the junior crew members, a young Kalani with nervous wing flutter, raised a tentative appendage. But what if we break something important? Me grinned. Then we'll fix it with something else. She held up a device that had clearly been assembled from components of at least 6 different systems. This little guy used to be part of the lighting controls, the food storage temperature regulation, and the waste heat recovery system. What does it do now? Asked the other crew member. Whatever we need it to do. The vanilla scent continued to drift through the ship's air systems. Every time Thok caught the sweet smell, he was reminded that humans didn't solve problems the way other species solved problems. They negotiated with problems until the problems gave up. 2 days later, when they reached the nearest space station, 7 different engineering teams requested permission to study Me's various modifications. She declined all the requests. Why? Asked the station's chief engineer. Because they're not systems, Me said. They're just stuff that works. She headed for the station's machine shop. There was apparently a problem with the artificial gravity generators that had been giving the engineering teams trouble for months. Thok followed at a safe distance. He had learned that, when Me started examining broken equipment, it was safest to observe from far enough away that you wouldn't get hit by flying parts. Within 2 hours, the artificial gravity was running more smoothly than it had in years. Me had also somehow improved the station's atmospheric recycling efficiency and fixed a persistent problem with the docking bay pressure seals. The station manager asked what she had done. Fixed them, Me said. Yes, but how? Me shrugged. Found the parts that weren't doing their job and convinced them to do their job. You convinced machine parts. Machines are just collections of parts with specific functions. If the collection isn't working, you change the collection until it works. The manager stared at her. That's not how engineering works. Me looked around the machine shop. Various pieces of equipment hummed with smooth efficiency. "Tell that to the machines," she said. That evening, in the station's recreation area, Senna found Thok staring at a maintenance manual for atmospheric processing systems. "Learning human engineering," she asked, trying to understand it. Thok closed the manual. "Every principle in here says what me did shouldn't work, but it does work. Better than it should work." They sat in comfortable silence for a while. The station's atmospheric systems cycled with perfect efficiency. Somewhere in the maintenance levels, me was probably taking apart something else that was perfectly functional so she could make it work better. "Thok," Senna said eventually, "do you think we're the ones who don't understand engineering?" Thok considered this. "I think we understand engineering. Humans understand physics. What's the difference? Engineering follows rules. Physics just follows what works. And humans follow physics. Humans follow whatever gets the job done." The next morning, they received word that me had somehow improved the station's waste processing efficiency by 30%, increased power generation by 15%, and solved a chronic malfunction in the communications array that had been puzzling technicians for 2 years. She had accomplished all of this using components from the recreational holography systems, the food service equipment, and what appeared to be parts of the station's decorative fountain. The station's environmental officer was quoted as saying, "I don't know how she did it, and I'm afraid to ask." The chief engineer submitted a formal request to the Galactic Engineering Council asking for new classification standards for non-standard technical solutions. The communications officer reported that the modified communications array was now receiving signals from frequencies that hadn't been detectable before. Thok understood all of their feelings completely. When the Harmony's Edge departed the station with its newly installed conventional life support systems, me kept all of her improvised modifications in place. "Just in case," she explained. "In case of what?" Thok asked. "In case it's Tuesday again." Senna's feathers displayed a color pattern that Thok had never seen before. When he asked her about it later, she explained that it was the color his species used to express the feeling of having one's fundamental understanding of reality gently but thoroughly rearranged. Thok realized he needed new colors too. A week later, they received a priority message from Galactic Engineering Command. Me's approach to emergency repairs had been designated as Human Standard Operating Procedure and was being studied for possible implementation across all mixed-species vessels. The message included a formal request for me to teach a seminar on applied physics in emergency situations. Me read the message and laughed. "What's funny?" Thok asked. "They want me to teach other people how to think like humans. And that's funny because thinking like humans isn't something you learn, it's something you just do." She deleted the message and went back to examining the ship's communication array. She had apparently decided it could work better. Thok no longer questioned human logic. He just made sure the vanilla scent cartridges were well stocked. After all, if they were going to breathe recycled air, it might as well smell nice. That was apparently what humans called Tuesday. But Thok was beginning to suspect that for humans, every day was Tuesday.